Topic 10-4, the last topic in geometry, first part of semester. This topic is on tessellations, can be referenced in our Holt textbook 12-6, 6th section on page 863 through 871. But I also want to reference mathisfun.com again. This is if you'll type in Tesselations, you're going to find some pictures and color, and they're explaining all the different kinds of tessellations that can be made. So if you see that word, you need to realize that what that means is it's another word for tiling, like putting tiles together on a floor, and you want everything to match up, where there's a pattern covering an area with repeating figures but no gaps and no overlap figures. So look at the tessellations online, and I'll draw a few. We'll do a few with this. What we need to understand is that if you want to be able to make something that tessellates and you're using a regular polygon, regular basically means that the polygon has all the exact same side measurements, and the angle measurements of each interior angle are also the same. So there is a formula that you can use to find the interiors of regular polygons, and that is 180 times the number of sides minus 2, all divided by the number of sides. So fill in your chart that we're going to determine which of these polygons will tessellate. So a triangle would tessellate because it measures one interior angle of one inside angle of the triangle would be 60. And if you take 360 and divide it by 60, you're going to get 6 angles. So notice how each one of these, if we take the interior angles of each of the polygons and divide it by 360, the only ones that tessellate are the 3 polygons that actually are factors of 360. And that would be the triangle, the square, and the hexagon. And again, if you'll look at mathisfun.com tessellations, you'll actually see a picture of that. But I'm going to go ahead and do just one of those examples, and that's the hexagon. If you take a hexagon and use our template, you can ask your teacher for one to test your own pattern making skills with regular polygons. But you notice that I can put all of these pieces together without any kind of overlapping and no gaps in the middle. They can all tessellate, and it makes kind of a honeycomb shape. So notice it can continue on and on and on. So yes, this tessellates. All right, and that's called a regular tessellations. There are semi-regular, and that would be an example when you use an octagon. This does tessellate, but not with another octagon. If I set this octagon and try to make it all match up, I can't make another one match. But if I put 2 polygon shapes together, I can create a tessellation. So this one, an octagon, can tessellate, but it tessellates with another polygon. You could probably notice what's taking shape in the centers here. Notice how each of these I can continue to make, well, probably not that pattern, because that's where the square needed to be. So actually I put those in the wrong place. But notice that these octagons with a square can tessellate. So this is a tessellation, but it's called a semi-regular tessellation. So once you've copied in this chart and realize that the interior angles have to be a factor of 360, we can determine whether something can tessellate or not. If you want to see if a regular 20-sided polygon will tessellate, using the formula, plug in 20 for your n, do the calculation, you get 162. But if you divide 360 by divided by 162, you're not going to get a factor of 360. So that 20-sided polygon would not tessellate. And so using that formula will help you decide whether something can tessellate. On this one it says sketch a tessellation using a regular polygon. Well, they want you to use a triangle. So all they did was graphically showing you can actually use a template if you want to borrow from your teacher. But they turned the triangle in different directions so as to not overlap but create the same thing going on and on. In example 3, this tessellation is going to use all 3 of these regular polygons. There's actually only 8 semi-regular tessellations, and you can find those on mathisfun.com under geometry tessellations. And I advise or encourage you to go look at that and create this tessellation by using either sketch, or you can ask your teacher for the geometry template. And that is the end of the first semester.